Good morning, everyone, and welcome to the Pilz Automation Safety Training, Intro to Safety in PAScal. PAScal being the Pilz software tool used to calculate performance levels and safety integrity levels of your safety circuits in your machinery. Our training today will be presented by Randy Price, our Pilz Channel Sales Manager, and Alex Smith, Pilz OEM Team Specialist. As a reminder, this is part one of a 15-part series of trainings we'll be presenting on safety standards as well as Pilz products and services. I hope you'll all plan on attending the full series of these trainings and that they will prove to be valuable to you in learning more about machine safety and how Pilz can help you achieve your overall machinery safety goals. With that, I'll go ahead and hand it over to Randy Price and let him begin our presentation. Randy?
Thank you, Ben. Guys and girls, appreciate your time and attention today. I'm going to do an overview of machine safety. Obviously, we can't do a deep dive into it because the subject matter could take days to cover. So we're going to do an overview of just machine safety and how to evaluate a hazard and so forth. Just an overview, if you will. Why do I need safety? And what are some of the effects of not considering health and safety issues? Well, the incalculable cost of human suffering, most of which is preventable, threatened consequence of prosecution and other enforcement actions, fines, lawsuits, a lot of ways that would cost you, potential loss of future business, because most companies don't want to deal with a company who has a lot of lost time injuries and fatalities and so forth, so it can cost you your customers as well as financially. U.S. statistics. These are 2014 statistics, but they're pretty accurate today. They're actually probably a little bit higher. 483,300 cases of non-fatal job-related injury and illnesses, which represents 4% of the manufacturing industrial workforce. And then 4,821 workers were killed on the job in 2014. That's 13 people a day that did not come home from work. Hard to believe that statistic is still that high with everything, all the standards and so forth that's put into place, but it still remains high. Why do I need safety? Murphy's Law. Anything that can go wrong will. The safety corollary is it is assumed that when present on machinery, a hazard will sooner or later lead to harm if no protective measure or measures have been implemented. We see a lot of people who have the attitude that we've run this machine for years, we've never had an issue, and that's a very dangerous attitude. And they'll be aware the hazard exists, but they just think, well, because I haven't had an injury, then we're okay. But it's still there, and it's a matter of time that it's going to happen. The cost of an accident, and it follows the iceberg model perfectly. You see the 1% that's above the waterline, and that's the direct that you see on the front end. The person got injured, medical expenses, so forth. But then below that are a huge amount of cost that are real financial cost, come right off the bottom line, legal expenses and retraining and all sorts of expenses that aren't necessarily looked at or high profile on the front end, but they definitely have to be considered. So when somebody's weighing, do I need to do more safety or not, they need to consider those factors as well. The OSHA Act is what we use here in the U.S. It was enacted in 1970, U.S. CFR 1910, signed by Richard Nixon into law. Each employer shall furnish each of his employees employment and a place of employment which are free from recognized hazards that are likely to cause death or serious physical harm to the employees. And they shall comply with OSHA promulgated under this act. So you got a number of standards that are in place in the industrial machinery market, and those standards have to be met, but this clause here catches anything that doesn't fall under any one of those standards. So it's the catch-all that somebody gets injured, they can't apply a individual standard, the general duty clause kicks in and they say, you, Mr. Employer, did not furnish your employee with a safe working environment. So that's the catch-all phrase that bites you if it doesn't come to an individual clause. What is machinery plant safety? Safety is the condition of being protected from or unlikely to cause danger, risk, or injury. As a machine manufacturer, safety manager, maintenance manager, production engineering, plant engineer, you should be aware that the worker of the machine at the machine assumes that the machine is safe, typically the operator. They have the assumption that since my company put me to work using this equipment, therefore it's safe, and that's not always the case. So it has to be taken into consideration the responsibilities, recognizing the hazard, maintaining good housekeeping, reporting safety hazards, working safely, using PPE, and making the most of safety training. And the safety training shouldn't involve just the operator. It should involve the maintenance people, the cleaning crew, everybody that interfaces with that machine. What is an accident? An accident is an incident plus a consequence. Incident is a series of actions or events, and the consequence is the outcome of the actions or events, which is typically an injury, lost time injury, or maybe not lost time. Common causes of machine accidents, reaching in to clear equipment. You got raw material jammed in the machine, getting in there to pull that out, or a tool left in there, something that causes you to get inside. Loading or threading materials into the machine. Not using lockout tagout. Unauthorized persons doing maintenance or using the machine. Missing or loose machine guards. See a whole lot of that. Machine guard gets in the way, and a lot of times they just take it off and throw it to the side. Ejection of parts or material. Here's the difference between hazard and risk. Hazard is the potential to cause harm. The risk is a combination of probability of occurrence of harm and the severity of the harm. Draw-in or trapping hazards. This is just a list with a brief description of each. Draw-in or trapping, that includes anything that can pull you into a nip point or a pinch point. Entanglement, loose clothing, gloves, hair, jewelry, anything that could get caught in a moving part of the machine and tangle you up or draw you in either. Cutting hazard can be rotating, it can be reciprocating or traverse. Impact hazard is object strikes the human body, a body part, but does not penetrate it. Crushing hazard, contact occurs when part of the body is caught between two objects. Stabbing and puncture wounds is, penetration of the skin by a tool or a piece of the machinery. Friction and abrasion hazards can be a burn from smooth or abrasive parts operating at a high speed. Here's some examples of each. We see these a lot with the pulley open, no guard over it. There in the middle, the sprocket and the chain, real good place to lose a finger or a toe, even depending on how hard that's driven and how big that is. Also, conveyor belts to drawing in, or don't know which way that one's running, but it could definitely have a pinch point involved. Entanglement, you can see every one of these has a good opportunity to catch you, catch your sleeve, catch your glove. Even these bolt heads on the spindle you wouldn't think of, but that would definitely catch you. Cutting hazards, like I said, there can be rotary, reciprocating, bandsaw. There's a real good place to lose a finger as well. Impact hazards, we see a lot of these on the left, the box square or a material that's stacked, and that is typically hydraulic driven, and you see there's no guarding around that. So somebody could be standing there, someone else operating the machine, and they drive that down, and if your foot's under there, it's going to be bad news. And this rotates, so you you've got the opportunity to get between where it rotates and fixed objects on the machine. And robots is a huge area of safety concern. Robots move from point A to point B, and you better not be between point A and point B. Crushing hazards, all sorts of contact of body part caught in between. So you got compactors, you've got presses, you've got all sorts of equipment that do various operations that can crush a body part or even a human. Stabbing and puncture wounds. Most of this shows, handheld equipment, but which definitely have opportunity to cause that. But there's also, vertical mills, drill presses, so forth that can cause these type of hazards. Friction and abrasion. Anytime they're removing some sort of material with a disc or a belt, you don't want to get your skin up against that. This is one of the most important slides that I'll show you today. This is something you can use over and over. ISO 13849 risk graph. This follows the ISO 12100 type of risk assessment that we at Pilz use internationally to assess a risk. And it starts on the left side, and the S's are severity of injury. So is it going to be slight? Is it going to be serious? So that determines which rung of this you follow. And then frequency or exposure time to the hazard. Is it seldom? Is it very frequent? And there's tables that tell you how many times per shift or per hour that would give you a 1 or a 2. And then that would determine, again, which rung of this ladder you're going to go on as you go across, and then possibility of avoiding the hazard or limiting the harm. This is a factor of how fast is the machine moving in comparison to hand speed of a human to be able to get out of the way, or and then the severity of the harm. So you're going to come across here and arrive at a performance level from low risk at A to high risk at B. What this determines for you is how much reliability do I have to have in the safety network of components to be able to satisfy the requirements of keeping an employee safe. We have a tool that's downloadable from the App Store. It is the Pilz PASMSI, and it does exactly this. It is a little handheld thing. You put it on your phone, you click the boxes that you want, severity, frequency, possibility of avoidance, and it arrives at a performance level. Now, this is just for reference only. This is not something to hang your hat on and say it is definitely a PLD because my PASMSI said so. It's more of a reference tool, guideline to get you in the ballpark, and then you really need someone with experience and a safety professional to tell you, do a deeper dive and tell you exactly where that thing comes in as far as performance level. PLR, just for your information, is the required performance level. So risk matrix, this is a different way of looking at basically the same information, but it's got a little more description. And it starts at the lower right and moves left and up, depending on severity and probability of occurrence of harm. So, likely, is it near certain to occur? Unlikely, not likely at all, may occur, remote, almost zero to occur. Catastrophic would be death, permanent disability, or injury, unable to return to work. So you're looking definitely, performance level E area here. And then severely debilitating injuries and illnesses, moderate, minor, just, general first aid when you get down in that area. Here's a chart. We get asked a lot about SIL level and how does it compare to performance level. ISO 13849, as I said, is performance level. IEC 62061 is SIL, which safety integrity level, typically used in process industry, not very often used in discrete automation like ISO 13849. And then if you look at this graph or this column, you'll see the probability of dangerous failure per hour, and you see that goes way up as you go down the list, or way down as you go down the list. This is a little bit different form factor of showing you some of the same information, but it breaks it into safety categories. And it takes into account the mean time failure to a dangerous condition, as well as it by performance level. So it kind of gives you a little bit more information, and it goes into diagnostic coverage, which would be coverage measure of fault detection of a safety function. This chart just kind of describes what I spoke about earlier as to, depending on your category, will determine what your control components in your safety network have to be to comply. And we'll go into that a little further. Okay, category B, which is a performance level A, 1 dangerous failure per 10,000 hours of operation. So you have safety-related parts or control systems, protective equipment, shall be designed, constructed, selected, assembled, combined, according to relevant safety standards and using basic safety principles. Single line here, input to a logic device to an output. The occurrence of a fault can lead to the loss of a safety function, and that's acceptable at a category B. Here's what your circuit would look like and your components in a typical Cat B. You'll notice each device is listed by its category. So when you're doing a safety circuit, you need to be aware that if any one of these fell below the other two, it would default to the lower value. So if I had higher safety level here, and this one lower, it would default to that one. It's the weakest link of the network. So you got a safety mechanical switch here, standard controller, and just a regular contact, single contactor operating a motor. We go to PLB, which is safety category 1. 1 dangerous failure per 100,000 hours. So now we use the requirements that we had in B, and well-tried components and well-tried safety principles. Now the occurrence of a fault can lead to the loss of safety function, but the probability of occurrence is lower than in category B. So we've got a little bit better components applied, so it's less likely for a probability of occurrence. But we're still single channel, input, logic, output. And here's what your circuit could look like. Again, mechanical switch. It is a positively guided, which means it's safety rated, and tied directly to this. This looks like it's a drive, but just single line, no redundancy. PLC, which is safety category 2, 1 dangerous failure per 300,000 hours. Same requirements as B, except now we're having well-tried safety principles applied. Safety function shall be checked at suitable intervals within the machine control cycle system. The occurrence of fault can lead to the loss of safety function between checks. The loss of the safety function is detected. So now we're looking for faults in the system by our logic device, and we're testing. So you see some redundancy here with testing, and we're doing a little feedback. Here's how this circuit looks. We've got light curtains, Cat 2 light curtain tied to the Pilz PSS 4000 safety PLC. This is just for your information, you'll see the green slices. Those are non-safe, and the yellow slices of IO are safety. So this PLC is capable of doing both. So we've got Safety PLC, which is Cat 4 rated in a Cat 2 circuit contactor. And we've got the breaker up here is a main contactor. So this is polling this. If it finds that that contactor can't break the safety circuit, then it defaults and goes back to this contactor and shuts down the entire. So this one would feed multiple of these, multiple motors. So it goes upstream from it and shuts off the main contactor to break the safety circuit. Performance level D, category 3, 1 dangerous failure per 1 million hours. So we've got requirements, same requirements as B, but we've got well-tried safety principles applied. Safety-related parts shall be designed so that a single fault in any part does not lead to the loss of safety function. And whenever reasonably practicable, the single fault is detected. Continued performance of the safety function in the presence of a single fault, detection of some but not all faults, possible loss of safety function due to an accumulation of undetected faults. So we're still monitoring. You see we're going redundant now. We've got redundant inputs, we've got redundant logic and redundant outs. We're monitoring and we're cross-monitoring. So we're doing checks in here and we're monitoring contacts. We're monitoring whether the safety circuit is made and broken easily as it should. Safety-related control design, Cat 3, this is the electrical version of it. So I've got 2 mechanical switches interlocked on the input side. This is a Pilz safety controller. This one happens to be a mini multi. So I can do redundancy in this. I can do testing. I can do feedback. So we got a feedback loop. We're monitoring 2 contactors operating a single motor. So if one of these welds shut and won't open, the other one should open. But this is monitoring all this through a feedback loop. Now we go to PLE. This is the maximum, the most dangerous hazards normally. And 1 dangerous failure per 10 million hours. So same requirements as B, well-tried safety principles. A single fault in any of these parts does not lead to the loss of safety function. And a single fault is detected at or before the next time demand upon that safety function. Accumulation of faults shall not lead to the loss of the safety function. So this circuit would see that fault. Say you had an e-stop with dual channel. One channel gets welded shut. It's going to break it. It's going to take you to a safe state, but the CPU is not going to let you reset the safety circuit until you clear that fault and that welded contact is fixed or replaced. And there's what that circuit would look like in redundance. The control hierarchy, ANSI B11. This is the preferred way to deal with hazards in a industrial setting. So the most cost-effective method is to do it on the design phase. So this is a service that Pilz, our engineering group, offers. You send us the drawings and we can go through it, and a lot of times eliminate a hazard right on the front end. So you don't have to worry about guarding it or safeguarding it. We can just design it out or reduce the severity of it. If that's not possible, then you drop down to guarding and safeguarding. So that's when you've got to put up gate interlocks and barriers and then presence sensing and all the other components necessary to safeguard a machine. After that, lights, you got stack lights, you got beacons, you got strobes, horns, signage, a lot of different ways to make somebody aware that they're a hazard. And then there's training and procedures. So how do you work safely with this equipment? And again, I've said it earlier, this needs to include everybody that interfaces with that machine, not just the operator, and then including lockout and tagout. And then the last line of defense is going to be personal protective equipment, which is your safety glasses, steel toe shoes, earplugs, whatever is necessary in particular job that that operator works in. Machinery safety life cycle is something that Pilz follows, and this is basically how safety should be done correctly. You've got a machine, you're not certain about its safety level. You have somebody come in. Pilz, again, offers this service, risk assessment. We come in, we assess the machine, we identify every single hazard on that machine, we rate it, we show you everything concerning that hazard, you know, which standard it violates and why and so forth. And then we go to the next hazard and we identify all the hazards. Then you go to safety concept. How would we suggest you mitigate that hazard? Is it put a gate there? Is it put a light curtain there? We'll do you a little conceptual on this is how we would handle that. Then that goes into design phase. Okay, how does that interface in your control scheme that you currently have on that machine? How will the safety fit in and what will it accomplish? Then it's implemented. So installed, got it up and running, troubleshoot it. Then we validate it. Does it work as it should? Did it do everything we thought it would do? When we're done with that, we still got this little area here that's residual risk that's still there. And there's always something there. There's a little bit of risk. Is it something we can live with? Is it tolerable? If it's not, we start around again. We assess again. Okay, we've still got some risk. What do we need to do now? And you go around the loop again. In addition to that, we do some other services. We do CE marking. If you need a machine that's going to go to Europe, it's got to be CE marked, and we can handle that for you. We do all sorts of assessments. We do NR12 if it's going to Europe. So our services group really offers a lot. That's really all I've got for you today. Hopefully I covered everything, and I will turn it over to Alex, who is going to talk to you about PAScal and walk you through that a little bit. I appreciate your time. Thank you very much.
Randy, this is Ben. The only thing I would mention very quickly is that in your pictures where you were demonstrating the circuitry for different category levels, the illustration shows 2 mechanical gate switches in order to meet the redundancy requirements for those safety categories. I would mention that if you use a higher safety rated to a category 4 safety rated switch, then you don't need to have 2 switches there. I just wanted to make sure that that was clear and no one was misled by the animation that you have to have 2 switches there no matter what. It is the opinion of Pilz that if you use a mechanical gate switch similar to what is shown, then that is what you would really need to do to meet safety category 4, because with the keyed switch like that, you have a single point of failure. But there are lots of switches offered by Pilz and our competitors that meet safety category 4 where you wouldn't have to use 2 switches there.
Right.
Thank you, Randy. Well done. Alex, would you like to go ahead?
Yeah. So thanks, guys. I'm going to take the screen over. So now that we've kind of, heard from Randy, what goes behind the performance levels and what actually helps us achieve these things, now we need to take that information that we've gathered and actually apply that towards our actual machinery and our circuits. So as Ben mentioned earlier in the presentation, we offer a software called PAScal, PAScal. It's our calculator that will help you determine safety levels that you can or have achieved on your machinery. So looking at my screen, this is what the software looks like when you open it up. So the first thing I want to do is just kind of run down through the structure of what all that you have here. So we'll start to left and move right. So on the left-hand side of the screen, this is where a lot of our work is going to start at as far as getting through some of the steps through creating a project. So we have 2 different tabs that I would like to make note of. One is the project directory, and another one's called workflow. We're going to be working out of workflow today, and this is literally going to give us a step-by-step help on how we walk through a PAScal project. As we create things through our workflow, you'll see our project directory start to fill up. So I'll make note of that whenever we start to actually create this project. The middle area of our screen, this is actually going to be our worksheet. So once I've created a project, we can actually start to bring in some of our components that are going to be used in our safety system into our worksheet. And then at the bottom, this is actually going to be the calculation graphs that kind of give me an idea of what I'm achieving so far, where I'm lacking, and kind of what I'm missing, if I'm missing anything at all. Below that, this is going to give us more of our the whole function, what target level we've achieved for our whole function, instead of the calculation graph is going to kind of give us our component level performance levels, if you will, or category levels. On the right-hand side of the screen, you're going to have our component collections at the top, and then on the bottom area, this is going to be actually where we store our libraries for our components. So whenever you open up PAScal, it already has some ISO and IEC related components in there, and then there's also the Pilz database that's already provided for you. We can import any other manufacturer's databases. One website that I personally use often is this one right here. And I go to this website and I can go to, we'll just say Pilz, for example. Scroll down to Pilz. This is going to take you to our website. The software that I'm working out of for PAScal right now is version 1.9.1. So obviously I could come up and grab this top file. I would save that to my computer and then come over here, and then I would import a new database. And like I said, you can do that for anybody else, any other manufacturer's components. But since today I'm going to be working with Pilz components, I already have that library in there, and I don't need to actually import it again. So now that we kind of know how things lay out, let's actually start a project. So the first thing I can do is come up to the top, and on this new tab, I'm going to hit on it. We actually just need to create a project. For our purposes today, I'm just going to call this sample machine. I'm the author, so I'm going to put in Alex Smith, and then this is version 1. The next thing that I want to make note of on this screen in particular is you're going to need to collect or select the safety standards that you want this project to abide by. So most often or not, like Randy mentioned, you're going to be working with PL, which is ISO 13849 referenced, or a SIL level, which is obviously going to go over to the EN 62061 standard. So since we're going to be working with PL today, because that relates more so to other machinery that we're dealing with, whereas SIL is more for process, we're going to keep it on PL. This area below that is going to be where we want our project to actually save on our computer once we're done with it. And then you can make any comment about your project in this below box as well. Once we've done that, we've now created a project, and you can see that in my sample machine and under my project directory. Like I mentioned, I want to work from the workflow because this kind of steps us through it a little bit more. So I've done step 1. I've got my check mark for actually creating a project. For my project, I'm going to have 2 safety functions on this machine. So let's create our first one by hitting the green arrow over here to the side, and it's going to bring you up another box that's going to ask to create a safety function. So we're going to call this one SF1, safety function 1. And in our description on here, I want to describe what that safety function is doing. So in my case, I'm going to do if door opens, drive stops. Just so I know whenever I go back and review this project, I know what my safety function was intended to do whenever I go back and look at this. Now at the bottom, this is where I either need to select my target level, or which is going to be your PL level, or I need to calculate that target level. So I already know that I want PLE, but I want to show you all how we would step through calculating our target level if we did not know that yet. So just as Randy showed you earlier, you walk through severity, frequency, and possibility of avoidance. Keep in mind, again, there is some subjectivity on a couple of these items, so I just wanted to make note of that one person may look at something a little bit differently than someone else does. But anyway, it would step you through here. So you do your severity, frequency, possibility of avoidance. After you've stepped through these things, it would tell you, you know, where you want to be at. So in my case, I want to be PLE anyway, so I can hit OK, PLE, OK. So now I've created my first safety function, which I now have this new tab, and you'll notice under my project directory, I now have SF1 underneath my sample machine tab. So I actually want to bring in the components that are needed for this project. So underneath my Pilz database, I'm actually going to type in 570500, which is a part number for one of our magnetic guard locking switches. This is what we call the PAScal S-lock. It's 500 or 1,000 newtons holding force, dual channel, power to lock, magnetic guard locking switch. So that's the device that I'm going to be using on my sample machine for the guard door. The next thing I need to do is actually bring in the controls that I'm going to be using on this particular project. And for this one, I'm going to be using our PAScal Multi-2 MV0, which is our part number 772100. Now, whenever I've dropped in this part, you'll notice that it's asked me for some additional information. Like I mentioned, this is a safety controller, so I could be using it in a number of different ways. So the software is just asking me basically how I'm using it for my project. In this situation, I'm using it for logic, dual channel. This isn't applicable because I'm working off the base unit. And after I've hit that in, it knows all the information now that it needs to know. This device, just to note, has 20 inputs and 4 safe semiconductor outputs, so it's a programmable relay that you can bring many devices into. And I'm actually going to be using that controller throughout this entire project for both of my safety functions that you'll see. So now that I've done that, I only need to do one last thing, and that's to actually bring in the output structure that I'm going to be using. So I want to go into this ISO section. I want to come into the output and actually look under the contactors. I'm going to bring in a nominal load contactor. You're going to notice it's going to ask me a few questions. This is actually where it's getting into talking about the diagnostic coverage, how often this device is being actuated or not throughout the day, and some of those things like that. So there's 2 different ways that I can input the number of operations. Either I can do the time between 2 operations, or I can do operations per time unit. I'm going to do operations per time unit, and I'm going to keep it at a per hour basis. However, I could change that to different increments if I wanted to. And I'm just going to say for my particular situation that this is done once per hour. And I'm going to say that the operational days per year for this machine are 180 days. And then I operate on 2 shifts plus a little service hours. So I'm going to put in 18. You're going to want to note this section at the bottom where it actually talks about that DC coverage that I mentioned. I'm going to put in here 99 because I want to make sure that my machine meets PLE. Note that if I would have put in 60% or less, it would have most likely took my machine immediately down to a PLD, if you're referencing some of that material that Randy had mentioned earlier to us. The only other thing I would mention under this dialog box is the attachment section. This is the section to where you could actually bring in information, operating manuals, system descriptions, things of that nature for the components that you're using in your project. So if at any time you wanted to attach some information to a project, this is an area that you can do that. So it could be beneficial for you as an OEM giving this information to your customer, or you as an end user just having one location to store everything and have it all in one area for you. So I'm going to hit OK, and that's going to drop in that contactor. Well, you can notice at the bottom that I've only achieved the PLC right now. Well, that's because I actually want to make that a dual output. So what I'm going to do is I'm going to right click on this section, and I'm going to hit number of channels, and I'm going to make that dual channel. So now that I've done that, I can actually drop in my next contactor. And again, I'm going to input the same information that I did before, just so I know that everything is matching up. And then once I've done that, you're going to see that I've now achieved a PLE on my output down here in my calculation graph. But if you look at my overall safety function result, for some reason, I still have not achieved PLE. All of my items are capable of PLE Cat 4, so that means my circuit should be. So what am I missing? The one thing that we're missing is a common cause failure editor. This little tab right here beside where I just was at. And what this is going to do is it's going to walk us through a couple of questions just to ask how exactly you've installed the components or plan to install, how are you using them, and some things like that. There's a couple of questions that you go through, not many, and as long as you are able to get at least a 65 or more by answering these questions, then you're capable of achieving that target level that you're going to do. So for time's sake, I'm going to go through here and just click a couple of these instead of going through one by one, just so you can see that once I finally got to that 65 number, now my safety function is achieved and I've actually gotten what I wanted out of it. But it makes me go through here and enter talk about some of these things to make sure that these components are, being used how they should be. So I mentioned earlier on that I was actually going to be creating 2 safety functions, and I was going to be using the same logic and outputs that I already had. So to make that easy on myself, what I would like to do is I'm actually going to highlight that part of my circuitry, and I'm going to right click on that, and then I'm going to actually create a macro. I'm just going to call this output for right now, and hit OK. Once I've created that, you'll actually see that it's now come up here underneath my macros in my component collections area. One other thing that I would like to note is that Pilz has already provided you a couple of sample things already to make it even easier on you. So if you go underneath this sample area, you can actually see that we already had 2 relays with a nominal load, just like I've made right here for you, actually already created for you. So just as a reference, there are a couple of sample components that Pilz has already provided up in this area. But back to my next safety function. So I wanted to create one more safety function for this machine. So what I'm going to do is I'm going to go back and I'm going to create a new safety function. And for this one, we're going to call it SF2. And this one is going to be if light, curtain, brakes, drive, stops. Again, we're going to be achieving a PLE, or we want to achieve a PLE with this, so we're going to leave it at PLE. Hit OK. That now is going to open me up a new spreadsheet to allow me to start making that next safety function. And you'll notice in my project directory that I now have a tree under safety function 1, and I now have another safety function included in that project directory. So I already know that I'm going to be using this as that output macro as my control and my output circuitry. So now all I need to do is go and pull in my light curtain. So what I'm going to do is I'm going to come down here and I'm going to use one of our PAScal light curtains. This one happens to be a hand protection 1200 millimeter, and I'm going to drop that into the project. And I've already created my entire circuit for that second safety function. But again, what am I lacking at the bottom? I still have to fill out the common cause failure editor. And the reason why that is I've now introduced a new component. It looks differently, so I need to re-go through here and just make sure that, again, I'm using things as they're intended to be used. But you'll notice once I get to that magic 65 number, now my second safety function, the target is achieved, and I've gotten to where I want to be at. So now I've created 2 safety functions. I have a project. What's the last thing I need to do? I want to generate the report for this project. And how I do that, I'm actually just going to click the green button beside it. And it's going to ask me to enter a couple of items. Now you can really customize this section if you want to, make a really cool template name, enter your company's name. You could even enter some symbols, maybe if you wanted your company logo or whatever that it might be. For me today, I'm just going to make it real simple and just put in sample, just so we can see what this report actually looks like. And like I mentioned, what this report is actually good for is this is going to give you some information in the case of you being an OEM to hand to your customer and say, hey, safety really meant a lot to us. This is what we did for the safety on this machine. This is how we achieved the PL level that was required to be achieved, and just kind of wraps all that up for them. If you're the end user, this is just a good thing to store along with your risk assessment to say, hey, we've done our work. Here's everything we have for that machine, and everything checks off. So it's just good to have all this information in one area. So this report should be getting ready to open up for us, and we'll scroll through it really briefly, and we'll see what all it actually has in there for you. So it's popped up. It has my project name, sample machine. It talks about what safety standard this one goes by, which we all know is ISO 13849, looking at performance levels. I'm the author. Again, this is where some of the comment section would be in here. And as we scroll through here, we're actually going to see more detailed information about the project as far as here's safety function 1. Obviously, my target was PLE. I achieved that target, and it tells me everything and why I was able to achieve that target. Some of the more particular information about the components can be seen down here. So for example, you remember when I had to enter the time between 2 operations for the contactors, all that information will be provided for you at the bottom of this report. It's a very valuable piece of information for you to be able to see because it's very structured and you're able to see inputs, logic, your output. So this was safety function 1. Again, like I mentioned, it's going to tell you all the components that you've used. And then again, it's going to go through the same thing for safety function too. So if I had a machine with 10 different safety functions on there, I would have all of this information provided as a PDF document that you could print out and hand to your customer, or do whatever you need to with it. And it's provided as part of the PAScal package. So as an overview to the PAScal software, that kind of brings that point to an end. And I'll hand it back to Ben for closing statements.
Thank you, Alex, very much. The only thing that I would add probably to what you had to say regarding PAScal is that while it does come with all of the Pilz products loaded on the software itself, you can also upload additional product libraries into PAScal for doing those calculations. So Randy, Alex, well done. Thank you both very much. Again, I appreciate everybody's time today, and a reminder that this is part 1 of a 15-part series, and I hope that you will join us for those additional trainings that we have upcoming. They will be very enlightening about safety standards as well as Pilz products and services, and I think they would be a very good use of everyone's time. So thank you very much. Everyone have a good day.